Hello, and thank you so much for joining me. This video will be the first in our series, in our Module 8 series, which will talk about or provide rather an introduction to statistics. So in this particular video, I am going to talk about scales of measurement. So just as a starting point, let's review a couple of things. So most of you from our previous discussion about research methods in the first half of the semester will recall that a variable is essentially any factor or characteristic that can be different either between different people or within the same person over time, right? So for example, we could talk about a variable of gender and say that one group of people are male and another group of people are female, and we're comparing potential differences between those two groups. We could also talk about change within a particular person over time, right? So for example, we could look at levels of depression before and after some kind of therapeutic intervention, right? So maybe your score on the Beck Depression Inventory starts out at a 50, and after 8 weeks of cognitive behavioral therapy, it's decreased to 30, right? So variables are essentially any characteristic that can change either between different groups or between the same person at different points in time. Right? So there are countless examples of variables that we've discussed, right? So for example, we could talk about gender, we could talk about education level, we could talk about eye color, weight, hours of sleep, memory ability, right? And there are a lot of different definitions we could use when we start to measure these variables or manipulate them in the context of an experiment, perhaps. So basically, anything that you can actively measure is going to be considered a variable. Okay. So it's very important to understand as part of your knowledge of statistics or learning of statistics, the difference between two different types of variables. So categorical variables are going to consist of discrete categories. And by discrete, I mean non-overlapping categories, right? Or another way to think about it is different levels, right? So again, male or female, Democrat versus Republican, eye color, for example, maybe blue, green, brown, etc. Okay, so discrete or non-overlapping categories. In contrast, continuous variables are numerical measurements, right? But a lot of different variables can be either categorical or continuous depending upon their operational definition. So for example, how might we define alcohol use as a continuous variable or as a categorical variable? Right? Well, if we're thinking about a categorical variable that's going to have discrete categories or non-overlapping categories, we could simply ask people, do they drink? Yes or no, right? So that would be a categorical classification. Or we could ask them about the number of drinks they consume, right? So we could just get a whole number value from them, right? So we could either say definitively, do you drink, yes or no, or we could ask them how many drinks they consume on average. Okay. So essentially what we're going to talk about today is we're going to talk about different measurement scales on which the variables that we're measuring lie. Okay, so what is a measurement scale? A measurement scale is going to be a classification system that researchers use when describing and analyzing dependent variables, right? So again, dependent variables or outcome variables are just the variables that you are measuring. Okay. So the different types of measurement scales are nominal scales, ordinal scales, interval scales, and ratio scales. And the first two, nominal and ordinal, are going to be reserved for categorical variables. And the last two, interval and ratio, are going to be reserved for continuous variables. So when we are trying to determine which type of scale we can use to measure our variable of interest, we have to consider three important properties. Okay? So the three important properties we have to consider when figuring out which scale is best for our variable. The first one is magnitude. So what I mean by magnitude is simply a property of moreness, right? So within this magnitude concept, right, higher scores on the scale are going to reflect more of an attribute, okay? So a higher score means more depression or more memory ability or something like that, right? Equal intervals. So equal intervals are essentially present if the difference between two adjacent numbers refers to the same amount of difference on the attribute. Okay, so is the difference between two adjacent numbers referring to the same amount of difference on the attribute or whatever we're measuring? Okay, so that'll make more sense in just a moment. And lastly, we have absolute zero. So absolute zero is essentially assessing whether or not the scale has a 0 point that refers to having none of the attribute. Okay, so magnitude refers to the property of a higher score indicating more of our attribute. Equal intervals means that two adjacent numbers on the scale are going to have the same amount of difference on the attribute as two other numbers, right? So there's essentially the same amount of difference no matter what two numbers you assess on the scale. And lastly, absolute zero is asking whether there is a 0 point that is meaningful, right? Or whether it's possible to have none of whatever attribute you're measuring, okay? And this is going to make more sense as we continue throughout this lecture. Okay, so one other important thing to note about these three properties of measurement scales is that they're basically arranged in a hierarchy, as you can see from this table here, right? So nominal scales have the fewest measurement properties and ratio scales have the most. of the properties, including all of the properties of the scales beneath it, right? So again, we have nominal, ordinal, and interval and ratio scales, and they go in ascending order, right? So nominal scales are the most basic scales, and they have none of the three measurement properties we just talked about, as opposed to ratio scales that have all three of those measurement properties. Okay, and again, this will make sense in just a moment. So what I'm going to do is I'm going to go through all of these four types of measurement scales and explain them in more detail. Okay, so our learning objective for this particular video is that you'll be able to identify the type of measurement scale and to understand proper use and interpretation of the scale. Okay, so let's start with nominal scales, right? So when I say nominal variable, what nominal means in this context is name, right? So nominal scales provide names for different categories, okay? And that's it. So because all they do is provide names of, or essentially category labels for a categorical variable, they are the least precise level of measurement, just because they don't provide a lot of information, right? So with nominal scales, there is a defined class or category by characteristics of an outcome that fit only one, right? So what does that mean? It means we have levels of a variable that are mutually exclusive, like I was talking about, right? So for example, we have a nominal variable might be gender, and the levels are male and female. A nominal variable might be ethnicity, and that includes Caucasian or African American. It might include political affiliation, which could be Democratic, Republican, or Independent. So most of the time, nominal variables are what are called dichotomous variables, which means they have only two levels, but it's theoretically possible to have more than two. So you might have one categorical variable with 7 different levels, okay? So usually they're 2, but they can go beyond that. Okay, so how do we input data from a nominal scale? Okay, so if we want to enter categories into a data set, we would simply substitute our category labels with arbitrary numbers, right? So for example, if we were looking at sex, right, that could be indicated in a data set by inputting 1 if the participant is female and 2 if the participant is male, right? So this is a process called dummy coding, right? Because the numbers are totally arbitrary, right? The numbers are essentially standing in for the category label, but they don't have any property of moreness or magnitude, right? Or another way of saying that is they're not quantitative at all, right? So they're just completely arbitrary, and they stand in for category labels, okay? And again, like I said, there's no limit to the possible number of categories with nominal variables, but usually they are dichotomous, meaning there are only 2 category levels, right? Like I said, male or female, etc. Okay. And again, variables using a nominal scale are inherently qualitative or categorical. Okay? What this means is that there must be distinct classes of the variable, but these classes have no quantitative properties, right? Therefore, no comparison can be made in terms of one category being higher or lower than the other category, right? So there's no natural order with categorical variables, or no property of magnitude with nominal variables. In contrast, we have certain variables that fall onto ordinal scales. So with ordinal scales, there are distinct classes, right? But these classes have a natural ordering or ranking, right? The differences can be organized on the basis of magnitude, right? So a great example of an ordinal variable is I personally listen to iTunes or Apple Music, and every day or every week or something like that, they always have a top 10 playlist, right? And the way that they determine the songs that are on this top 10 playlist is by the number of downloads, right? So the number one song is obviously going to have more downloads than the number two song, right? Or certainly the number 10 song, right? So they're ordered on the basis of magnitude, in this case, the number of downloads, right? So the number one song can be separated from the number 10 song or even the number two song on the basis of magnitude or having more of a specific property, right? But ordinal scales, while ordinal scales are organized on the basis of magnitude, right? They do not assume that the intervals between numbers are equal, right? So given our current example of the top 10 playlist, right, it's entirely possible that the number one song gets 300 million downloads, right? And the number two song gets 300 downloads, and the number three song gets 50 downloads, right? So they're all still ordered on the basis of magnitude, but the distance between the number one song and the number two song is not the same as the distance between the number two song and the number three song, right? So ordinal scales do not assume equal intervals. Another classic example is the final position of horses in a race, right? This is an ordinal variable because there are horses that finish first, second, third, fourth, and so on, right? And they're ordered on the basis of magnitude, right? The horse that finishes first was able to obtain a faster speed than the horse that finished second and third and fourth and so on, right? So there is a natural ranking or ordering that's present. However, right, the difference between first and second, right, is not necessarily equivalent to the difference between second and third and fourth, right? So the distance between first and second was longer than the difference between second and third, right? But shorter than the difference between third and fourth, right? So even though there's a natural ordering here, we don't assume an equal distance between any two numbers on the scale, okay? Okay, interval scales do designate an equal interval ordering, okay? So the distance between 1 and 2 is the same as the distance between 4 and 5, okay? So interval scales are going to have magnitude or the property of moreness, and they're also going to have equal intervals, okay? But they do not have a meaningful 0 point, right? So let me give you some examples. Okay, my first example is Celsius temperature, right? Or temperature on a Celsius scale, right? With a Celsius scale, it's meaningful to say that 25 degrees is 3 degrees hotter than 22 degrees, and that 17 degrees is the same amount hotter, 3 degrees, than 14 degrees, okay? So notice, though, that 0 degrees Celsius doesn't have a natural meaning in this temperature scale, right? So 0 degrees Celsius does not mean the complete absence of heat, right? And similarly, if I were to ask people to rate their confidence on a Likert scale from 1 to 5, right? The distance between 2 and 3 is going to be identical to the distance rather, between 4 and 5, okay? But there's nowhere on the scale where they can indicate an absence of the variable, okay? So there's no meaningful 0 point here, okay? Okay, and lastly, we have ratio scales. And ratio scales are going to include all 3 of those measurement properties that we've talked about. Okay, so ratio scales are going to capture the properties of all of the other type of scales, but also contain a true 0, which accurately represents the absence of the quality being measured, right? So again, let's look at some examples. Heartbeats per minute has a very natural 0 point, right? 0 means no heartbeat. Weight in grams is also a ratio variable. Again, the zero value is meaningful because 0 grams very clearly indicates the absence of weight. Okay? Similarly, the number of intimate relationships a person has had, right? 0 quite literally means none. And the reason why we call ratio or variables in this category ratio variables is because we can also compute ratios if we have a natural 0 point, right? So a person who has had 4 relationships has had twice as many as someone who has had 2 relationships, right? So when we have a meaningful 0 point, we're able to very easily compute ratios, okay? So again, both interval and ratio scales are going to deal with continuous variables or numerical variables, right? Like asking someone how many drinks they have per week or per day. And categorical variables are going to be indicated with interval and nominal scales. Okay? Okay, so just to summarize, okay, nominal scales are qualitative, not quantitative, because there's no absolute 0, no equal intervals, and no magnitude. Ordinal scales They rank individuals on the basis of magnitude, but there are no equal intervals and no absolute zero. Interval scales have magnitude and equal intervals, but no absolute zero. And ratio scales have magnitude, equal intervals, and absolute zero so that you can compute ratios. Okay, so you guys are going to be able to practice naming the appropriate scale in your homework. And certainly if you have any questions, please don't hesitate to reach out, and I will see you in my next video.